Welcome everyone to our Titan 9 Mastercam tutorial. Now that you've made the part, we need to start seeing about actually making the part. You can see I've got it loaded up here. I've already chosen my Haas 3-axis vertical milling machine. You could probably run default mill if you don't have this as an option. Like always, we start off pretty similar. We're going to go to our levels, and I'm going to make sure level 1 is body, and level 2 is going to be stock. There we go. All right. So with that, I want to go ahead and make my wireframe just like always. So I'm going to go up to wireframe, and I'm going to choose bounding box. I'm going to make sure it's going from the center top. I'm going to pick my part and my selection. I do know that my Y is always 2 inches, and my Z is 0.98. We always do that because we shave off 20 thousandths. I can tell you I've looked on my chart, and our X is 6.1 inches long. My chart meaning my my spec sheet for this project. Make sure solids is checked, hit OK, and now I have a solid model. Well, I have a wireframe showing my bar of stock. I'm going to go into tool paths. I'm going to hit stock model. I'm going to call this stock. I'm going to uncheck stock plane because that's not how we're going to line up. I'm going to hit model, and then I'm going to triple click my model here to create my stock model that is now there. I'm going to hit save again, and I'm going to go ahead and put my G54 in right there on the top left corner. I'm going to change its name to G54. And most of the time we offset our origin plus 50 thousandths in the X, and then we do minus 50 thousandths in the Y. That is kind of our standard. Other shops may do things differently, but that's kind of usual for us. I did click it. Let's see if it got crazy and moved. Of course, it did. So I'm going to edit it again. Put it back on that corner. 0.050. And then negative 0.050. Cross our fingers and hope it doesn't go crazy. All right, it's good. Yay. We'll hit save real quick. Next thing we need to do is we need to load up our tools. So we'll go to Tool Manager. And I'm going to search for my tool library is saved. Mine is saved in my Titans, not Titan Cycling, Titans of CNC, and I'm going for library number 2. Okay, so I need a 2-inch face mill. I need a 1/4-inch flat end mill. I need a 1/2-inch flat end mill. I need the 1/4-inch chamfer mill. I need a 1/4-inch drill. And then I need my spherical end mill. We're going to load all those up. First thing I want to do is, well, let's go back to make this my active level. Let's see, I've done everything up to now. We're good. So we're going to do a facing toolpath. I'm going to make sure I'm picking the face. Click OK. Our tool is going to be our number 1 2-inch face mill, and I will put face off part. Cutting parameters, I like to do zigzag, like so. We are going to leave no stock. I will have it a little bit off the edges. I'll just do 10% so you can see it just overhangs. It starts 0.2 away. And my move between cuts, I do high-speed loops. Our linking parameters, make sure all these are set to absolute. We're going to go absolute 0 for the depth and top of stock. Technically, our top of stock is at 0.2. Or 0.02, sorry, 20 thousandths above. But we're not even going to worry about that right now. We'll change this guy to 0.1. We'll make sure our planes are set to G54, and we will make sure our coolant flood is turned on. And there we go. We got a nice facing operation. Save that guy. I'm going to go in here. I'm going to turn off that level, and the stock here was turned off, so I'm good. And as you all know, traditionally, our first or our second step or our second tool path is OptiRough. So we're going to stick with that. I'm going to leave 5 thousandths just like always. Okay. So I'm going to change this to 0.005. So we're leaving 5 thousandths on, not 50 thousandths. We're going to select our model by triple clicking this guy. Our toolpath control, remember, we're going to tell it now where it's allowed to go in and out. So I'm going to change this to edges. I'm going to hold down Shift, pick there. So pick that whole thing. I'm going to allow it to go outside of that by 1 inch. My tool is going to be my 1/2 inch flat end mill, and I will say Opti Rough Toolpath. These numbers are pretty good. We can actually go a little bit faster than this, to be honest with you. We can go 45 and 4500. For our stock, we're going to tell it to use the rest material, and we're going to compute the remaining stock based on another operation, which is our stock model. For cut parameters here, we're going to do climb. We're going to optimize by depth. Well, see, what we could do is we could optimize by pocket, because we're going to have 2 pockets on each side. So otherwise it would do like one level, jump over to the other pocket, do the same level, then jump back and do another level. You'll have a bunch of jumping back and forth. So by pocket, we'll make this more efficient. My step over distance, it depends on how conservative you want to be. 25% is not too bad. We're not cutting a lot there. Let's go a little high. Let's go 35% just so that we're not taking forever. Our step down, we're going to go 0.76 because we want it to go all the way out the bottom, and we need to allow it to step up. Okay, steep shallow we have to turn on, and we have to adjust for the stock to leave, and we're going to go negative 0.76 is going to be our maximum depth. Linking parameters, we're going to change this to 0.2, and then honestly most of these defaults are just fine. We don't really need a ramp angle. I mean, I can take that off, but none of these are going to make a tremendous difference for us. Planes are set to G54, and I want to again make sure my coolant flood is turned on. Let's take a look here. It says the bottom of the stock is above my maximum depth. That's correct. I want it to hang out at the bottom. And there we have our toolpaths. Okay, I'm going to hit save. Now I could backplot this guy just to see what she looks like. And there we go. We're going to plunge down, cut out that pocket, rough cut it out. Okay, we're going to go around the outside edge, going to cut out the little notches. Good deal. We're going to cut this pocket out. All right, good deal. What else we got going on here? Oh, we're going to cut off that ledge that's up there. Okay. This is where it'll start rough cutting that surface. Okay. So this is going to get us in the ballpark. All right. So we're looking good with just that. That I'm pretty happy with. Now we do have stock remaining, so we're going to go ahead and take that off. We're going to start with a contour, and we're going to pick this outside edge. Remember, we have about 5 thousandths left on there, so I'll hold down Shift. Not about 5 thousandths. We have 5 thousandths left on there. All right, so again, we're going to do our 1/2 inch flat end mill. There is not a lot of material left here. I am going to go fast. So I'm going to go 60 inches per minute and 5,000 RPM, and I will put finish contour outside edge. For my cut parameters, this is going to be a finish cut, so I'm going to change it to where. I don't need depth of cuts. My lead in, lead out, I don't want to enter and exit at a midpoint because that means it would come in right here, and that might leave a little mark. So I'm going to undo that. I'm going to change these to perpendicular so we're not wasting a bunch of time or not adding like extra motions. I like the 30%. And then we don't need breakthrough. We don't need all these. We're going to linking parameters. We want everything at absolute. Okay. So I'm going to do absolute 0.1 and absolute 0.2 for these guys. My top of stock is still 0. How deep am I going to go? Well, I want it to hang out the bottom a little, so I'm going to go negative 0.76. Okay, that's the same amount we went down with the Opti Rough. My planes are G54, and let's see, my coolant, I want flood on. Let's take a look here. Okay, simple toolpath. Okay, now what you can see here is the way it starts. There's no looping it goes in. So if I want to change that, which I think I will, is I'm going to go to lead in, lead out. and I'm going to make both of these tangent. We'll take a look what it does here. It does nothing. That's fun. All right, we're not going to worry about it. It is not going to hurt anything. We're not making a big cut anyways. Now, we do have material left inside these holes. We have material left on this wall. We have material left on this wall, and material left on the floor. Doesn't really matter what order you go in. I'm going to do the lowest one first. So I'm going to hit contour. I'm going to pick this bottom circle. Now, if I went this direction, that would not be climb milling. So I'm going to reverse it. Hit OK. My tool, it's going to remain that 1/2" flat end mill. Again, there's hardly any material, so I can go very fast. And I'm going to say finish cut through hole. And my plunge rate, it's going to plunge not in material, so I could even go to 100. I can go really fast. My cut parameters are set to where. That's good. I don't need depth of cuts. My lead in, lead out, I'm going to leave at 30% because it's a nice number. Linking parameters, make sure these guys are all to absolute. Good, good. My top of stock is 0. I'm going to go down to -76, just like we've been doing. Planes are at G54, and my coolant is set to on. So if you look in there, there's my cut. Now I need to do this one because my diameter is not the correct. It's 5 thousandths too small, and this ledge is too tall. So I'm going to hit contour again, pick this ledge. This time I am going the correct direction. That would be climb milling. I'm going to go ahead and pick that same tool. Remember, it's 60 and 5,000. Now I could say finish cut. Now this is a counterbore hole because it has a ledge. My cut parameters are set to where. Good deal. Lead in, lead out. Everything's the same. You're at 30%. My linking parameters. Okay. I like these numbers. It automatically picked the 0.5 because it's 0.5 below. I could check my drawing. I could also do this. I hit depth. When I pick that ledge, you can see it picks it. Planes are at G54 and coolant is set to flood, so we're looking good there. All right, so it goes around and machines that ledge. I'm going to hit save now because God knows what could happen. All right, so our order here, we got a lot of things we could do. The thing that's going to take the most amount of time, cycle time, is these ledges. They are going to take a lot of time because you have to do this with a ball end mill. And that means it's a spherical and you make very small steps. And there's with a 3-axis mill, there's no way around it. This is what we have to do. So what I think I'll do is I'll machine these flats. Now I could just hit it with a face mill, just come right across here, this surface, and it would probably work. The transition won't be that great, and maybe what we'll do is later on I will do one where we just mow across this, and we'll do one where we do the ball end mill, and you can see the difference. But let's go with the ball end mill. We're going to go with the prettiest one. So we have saved lately, and what I'm going to do is I'm going to fill these holes in. It makes it easier for me selecting stuff. We don't do a lot of modifying of parts in Mastercam, so we should every now and then so that we're somewhat versed. So I'm going to go to my surfaces here, and I want to fill the holes, but here's what I want to do. I want to be able to turn that fill on and off, so I'm going to go to levels. I'm going to make number 3, and I'm going to call it like hole plugs, something like that, okay? It's currently my active one, and it's visible. That's what I want. I'm going to tell it fill holes, okay? All I have to do is, this is the surface, and then it wants to know, what are you filling? That. Same deal again. Surface, fill that hole. Surface, you just got to get pretty close. Fill that hole. Surface, fill that hole. We're all good. All our holes are now filled. I'm going to save that guy again. I'm going to leave that turned on. All right, so now if you go to your toolpaths, you're going to start looking at these 3D guys, okay? So this is a flat area we're going to machine. So we're going to use this thing called, let me get to it here, raster. So click that. Okay. And this time we are going to leave nothing. This is going to be a finish cut, so we don't want to leave anything. Now I'm going to choose it. I want to pick that surface, and then I want to pick that surface. Those are the two things we're going to cut. And selection. Toolpath control. Okay, this, we're going to tell it what it's allowed to go either outside of or inside of. Now the settings in here are going to be somewhat similar to OptiRough. Not exactly, but somewhat. So we're going to go into our model geometry, and we are going to have no stock on the floor or walls, and we're going to pick it. So we want to make sure that we pick those, right? We already did that. Then we're going to go to our tool path control. We're going to pick boundary chains. Okay, you're very used to this. And I'm going to see if I can pick a surface. Yeah, there we go. I'm going to pick those surfaces right there. Perfect. Okay. And with those, I want my tool, I could tell it to say inside, but it won't go all the way to the edge. So I'm going to go to the center of that line. No, I want to go outside of it. I'm going to go outside of it by, we'll just say 50 thousandths is a bit. So I think we're just going to go by 10 thousandths. Okay. And we don't want to include the tool radius. We just want it, the dead center of that tool to overhang by 10 thousandths. Speaking of tools, we're going to pick our 1/2 inch spherical end mill right here. Okay. We haven't used one of those before, and because it's hardly cutting anything, we are going to go very fast. We're going to go 70 inches per minute for our feed rate. We're going to do 5,000 RPM. We're going to plunge at 50, and we'll tell it right here. We'll say finish, cut, not flat surfaces. Okay, so if we move on down, we're not going to do anything with stock. We just need to jump down to cut parameters. Okay, I'm going to let it do a zigzag pattern so it'll work back and forth. And I have to keep my step over pretty small, otherwise you will see ledges or little ripples or whoop-de-doos or whatever you want to call them. So I'm going to go 5 thousandths of an inch. I'm not going to worry about the scallop height. Okay. If I go down to my steep and shallow, this is the angle when it makes cuts. We'll just leave that default. I don't have to worry about anything else. For my linking parameters, I'm going to do a clearance of 0.2. And then let's see, my default stuff here, sweep angle, radius. All this will work just fine. This isn't going to have a killer deal on me. Keep tool down within 100% of the tool diameter. There's no reason it needs to lift here because we're machining flat ledges and we want smooth transitions. Okay. Make sure our planes are set to G54. Make sure our coolant is turned to flood. And we'll take a look here. All right. Now, if you zoom in close, there's what we're doing. You can see it's going to be going back and forth a lot. Now, later on, we can talk about how to fix this. All right. So our next step we want to do is we want to machine the middle surface, kind of the most complex thing we're going to do. So we're going to do this tool path called equal scallops. Interface is very similar to our last one. It's also very similar to OptiRough. It's gonna be a finish cut, so we're gonna leave no floor and no wall stock. We're gonna select our geometry. We want to pick all of these surfaces. Oops, got ahead of myself there. So I'm gonna pick these guys. I also need to pick that surface right there. All right. Tool path control. This gets a little sketchy on me. Now we're supposed to be able to use this silhouette thing, and man, it would not work right for me. So we're going to do these boundary chains. And what we're going to do is this. We're going to click that. We're going to pick edges. It doesn't really matter where you start. I'll just start here. Arrows going to the left, which is what we want. And we're just going to hit next. Okay. See that red arrow right there? That's where we want to stop. We're going to hit adjust to turn directions. Boom. Adjust again. And then we're going to keep walking around it. Okay. I got to adjust again right here. And then keep going. Keep going. Keep going. Adjust. Adjust again. One more adjust. Remember, it chases the red arrow. All right, there we go. Next thing I got to do is hit end chain. Okay, I'm going to pick a new chain, which is that circle right there. All right, so now we have all those things. Or we have our kind of containment picked, all right? So we're going to choose this trimmed offsets. We're going to contain the tool tip. We're going to allow it to go outside that containment boundary we made by 0.05, but we're not going to include the radius because otherwise it goes way out. It goes half the diameter of the tool, which is the radius. And then I want to give it a curve to like, hey, don't cut inside here. So I'm going to click select and I'm going to pick that circle. Otherwise it's going to try to machine inside. All right, so I think I've got everything good to go on there. We're going to move down to our tool. We're going to pick our 1/2 inch ball end mill. We are going to go really fast, 70 inches per minute, 5,000 RPM. We're going to plunge at like 30. We could probably go more. And then I'll put 3D machine center area. I mean, I don't know what else to call it, but that'll help me know what's going on. Skip down to cut parameters. And if it's a closed contour, I want it to do a counterclockwise spiral. If it's an open contour, I want it to do zigzag. I want smoothing turned on. And if you look at these guys right here, that distance, just like on our last one, we want it to be 5 thousandths. It's really tight, I realize, but it'll make things look very nice. In our steep and shallow, we got to turn these guys on. We're going to tell it to include stock. And we're going to hit detect limits on both. So that tells it how far to go down. Under our linking parameters, we're going to go with 0.2 for our retract. And then anytime it has to go over, right now if it would be 100, if it has to lift up or machine up a curve or an angle that's taller than 1/2 inch, which is 100% of our tool diameter, it will lift. We're going to do 40. Coolant should be turned on. And just to be sure, planes are G54. All right, let's take a look. Don't feel bad if you make mistakes on this one and something doesn't look right. I struggle with this one from time to time and scratch my head. Lots of new things, lots of settings that you're not used to dealing with, but with repetition, you'll start to get better at it. And she's still thinking. All right, there we go. So you can see it just goes over the edges a little bit. And we have our nice curved surface. What you will see is when we make these, this is why it takes a very long time. This is why we would charge a lot of money for this part. Okay, I hit save so that I'm good. Now, I've machined this flat surface. I've machined this curve guy. Now I have these surfaces to deal with. Those are my next ones on my kind of to-do list, if you want to think of it that way. So again, I'm going to use that equal scallop deal. So I'm going to hit equal scallop. Okay, set to 0. That's good. That's what we want. And for our model geometry, I think, unless I'm mistaken, let me think this through. I'm pretty sure I can go in here and just pick the whole thing. Okay, pick the whole thing. It'd take you forever to pick all this stuff in here. Okay, toolpath control. Let's see what we want to do here. We're going to pick this edge up here, and it's on both sides actually. So we're going to pick, if we go in here, I think I can pick a loop. Let's see what happens. Give it a try. It's picking weird loops. All right, maybe not. You might be able to get it to work, but I'm just going to pick an edge, and I'll just start here. And then I will work my way around. That way I don't lose my mind trying to deal with that. Then hit end. I'm going to do it again over here. Make sure you're at the top. I'm kind of fighting that right now. There we go. Hit next until I come all the way around. All right, looking good. All right, so that's going to be my containment, right? I'm going to go back to closed offsets because this is a closed area I'm staying in. I'm going to contain my tool tip. I'm going to stay, well, I want to be inside of it, but if I hit inside, it'll be like inside the whole diameter of the tool. So I just want to be inside via the center. Okay. Let's see here. I don't need a starting point. I don't need any curves to avoid. If I had an area to not machine, that's where I would click that. My tool, once again, we're picking that guy, the 1/2 inch ball end mill. We'll do 70 again. We'll do 5,000. We'll plunge it. God, God, we could go 50. And I will put on here 3D machine pockets. That sounds good. Most people would know what's going on with that. So next thing we have to go down to is cut parameters. We're still going to stick with a counterclockwise spiral. Now, zigzag would probably work, but we're going to go one way for open contours, and that'll ensure everything looks really smooth down here. I don't want it to go from the inside to the outside. I actually want it to go the opposite, outside to the in. So I'm going to actually get rid of all these. Okay, my step over is still going to remain 5 thousandths. It's going to drive you nuts. Maybe we'll play with this on some other programs just to see what it looks like if we increase it. Our cycle time will drop, which is nice, but will our quality drop? That's the thing we're going to have to check. Okay, steep, shallow. I'm going to uncheck these guys because I'm actually going to set this. And then when I go to linking parameters, okay, let's see here. I can change this back to 100% because we're not really doing anything crazy. Yeah, nothing else interesting there to really deal with. My planes are set to G54 and my coolant should automatically be turned on because it remembered things. Cool deal. All right, let's take a look. Might grind on this for a while. There's a lot going on here. And there's 2 of them. This is why, let's see, I was going to say this is why companies pay a lot of money for those fancy high-speed processors so they can mow through this faster. And still thinking. Oh, there we go. Okay. So, looks like it's all filled in. If you want, well, I'm going to save before anything goes wrong. Let's do a back plot real quick on here. Okay. So it does a little bit on the bottom, and then it works its way outside in. Remember, I didn't go inside out. Okay. Goes over to the other one. And it's going to do the same thing. This is my speed, so we can go even faster so that I don't lose my mind here. All right, looking good. So that's really the hard parts. Those are things you might not have done. We have a few more things left, obviously. But those are the things where you're like, wait, I don't know how to do these. So let's go back to the stuff you know how to do. Make sure I've saved just because, man, oh man. We got to deal with these holes, and we got some chamfers. That's pretty much all we have left at this point. Okay, so before we drill those holes, we're going to do a spot drill. But that means we're going to have to turn off our hole plugs. I got to move this to my active level, turn those hole plugs off. Cool. All right, so under drill, I have to pick my circles. Remember, it is going to do it in the order you pick them unless you tell it otherwise. All right, cool. And then for my tool, I'm going to pick my 1/4" chamfer mill. And since I am actually chamfering, since I'm spot drilling and not actually chamfering, I don't want to go this fast. I'll go 20. 5,000's probably fine, but let's go down to 4,000, not 400, 4,000. And I'll say spot drill holes. Cool deal. We don't need to worry about the holder. We don't need to worry about the stock. Cut parameters, this is where we want to change it to. It's just a drill. Okay, we're going to call it spot drill. But we're just drilling, okay? So if we go down, the next thing we're worried about is linking parameters. Let's make sure these guys are all absolute. Now, I'm going to need clearance because I need to go above something that's up there. And, I don't want to break anything, so I'm going to change this to 0.2, okay? So when it rapids over to the opposite side, it goes up to 0.2. So from here to here, it's actually below my 0. It's below my 0 by negative 0.2. So we're going to rapid down to barely above this. Okay? My stop and stock is 0, and how deep do I want to go? I'm going to go negative 0.337. Whoa, not that number. I'll get there eventually, right? So let's see. We want to make sure my planes are G54 and my coolant is turned to flood on, and we should get ourselves some spot drills to help guide our drill later on. All right, cool deal. There we go. And you see, we're gonna, remember, yellow is rapid, so we're going to rapid down to here. Spot drill, wrap it up, wrap it over, wrap it down, spot drill, wrap it up, wrap it over, wrap it down. This is gonna, it doesn't seem like a lot, but it definitely makes things faster. Okay, so we have our spot drills. That would mean our next thing we need to do is drill. I haven't saved lately, so I'm gonna hit save. All right, let's drill. Again, we're gonna pick those holes. Come on, there we go. Okay, our tool is going to be our 1/4 inch, what it says a jobber drill, but that's just kind of a standard drill bit. That's the drill bit you would buy at like a hardware store as far as lengths. Okay, so how fast we want to go? Let's go let's go 15 inches per minute. Let's do 4,000 RPM, and I will say drill 1/4 inch holes. And the reason it's a 1/4 inch is that's a 1/4 inch hole out the bottom. Not worried about holder, I'm not worried about stock. Cut parameters, I am going to chip break. Remember, it means it goes down, stops, down, stops, down, stops, just to like break up the chips. If I change this to peck drill, it goes down, lifts all the way out, down further, lifts all the way out. It takes way longer, which is good for deep holes. But we're just going to chip break because we are not going that deep. The only other thing I'm worried about here is this right here, my linking parameters. Most of them should have saved. Looks like they did. The only thing I'm worried about is I want to come out the bottom. So for just the tip, I would go negative 0.76. But because I have a a pointy tip on it, I'm going to go out negative 0.86, or just 0.85 is probably far enough. Okay, planes are at G54. Coolant should be flood on. Let's see here. Yep. And there we go. Those are our drills. Okay, and you can see it comes out the bottom. If, after I hit save, of course, if I ran my back plot and you just go step forward, watch your drill. So it's pecking, or not pecking, it's chip breaking. And you see it sticks out the bottom. That's what we want. So we'd be all good. All right, now we have holes drilled, but what we don't have is these counter bores. So we got to do those, and we'll do those with a circle mill. So if I look in here, I'm looking for my circle mill right there. Cool. I'm going to pick the ledge, the outer of the ledge. Okay, so I'm going to pick that guy. Come on, that guy. And that guy. All right, cool deal. All right, so there's my geometry pick for my tool. I'm going to use my 1/4 inch flat end mill. And let's see, I say it defaults to 20 and 5,000, which is probably fine. 5,000 spinning pretty good. We'll stick with it. Now, it is going to be plunging. Oh, no, it won't be plunging in the metal. We've already drilled. So 50 is probably fine. And then what we'll do is counter bore holes. Okay. I'm not worried about anything else until I get to cut parameters. My cut parameters, I don't want to leave anything. This is a finished cut. Okay. I'm going to set it to wear. And then for roughing, I do a roughing, but I don't want to do this helical entry. I'm so tight in there because it's a 1/4 inch hole. If I do a helical entry, I'm just, I just want it to drop down and start cutting. So I'm going to turn that off. My step over, if I step over 50%, that you're asking kind of a lot of a 1/4 inch end mill. So we'll do 20%. We should probably do a finishing pass because these are counterbored holes. It's probably kind of important that they're the right size. So we'll do one finishing pass, and it's one here. And a common finishing pass is 5/1000, at least for the work we do. Okay, and we'll keep it down when it does that. So it'll finish pass, drop down, and it'll do a finish pass on the or it'll drop down, it'll cut, and it'll stay down, do a finish pass. Then it'll move to the next hole. Linking parameters, let's see what we want to do here. So these are kind of our normal numbers. Okay, so our retract is going to be 0.2. Our feed plane is going to be 0.1. Our top of stock is 0. And we're going to go to negative 0.5 deep. How do I know? I can click that depth. And I can click that. And it tells me negative 0.5. Okay. Now, if you're worried about this 0.2, remember it's 0.2 above the origin, which is the top surface. So we're cool. Planes are G54. Coolant is ignored. No, we need that on. All right. And there we go. You can see it drops in and spirals around. All right. We're getting there. We are getting there. Our next things we have to do, it's all chamfers. It's all chamfers from here on out. So I'm going to do the easy ones first. Okay. We've got a chamfer to do on these holes. We got a chamfer to do on this circle. Okay. Those are easy ones. You guys are used to those. So I could do those as a contour. Okay. So I'm going to pick that hole, that hole, that hole, that hole. Now, the one thing I was worried about is one of those appeared to be going the wrong way. Oh. I uncheck that one, check that one. That one actually is going the right way. Let me look at these guys. This guy is going the wrong way. That would not be climb milling, so we're going to reverse it. This guy right here is going the correct way. We want it to be going clockwise. This guy right here, oh, I got two things picked in there, great. This guy's going counterclockwise. Let's see what's going here. That guy's going counterclockwise. No, clockwise. That one's good. All these guys are going clockwise, which isn't what we want. All right, let's reverse it. That one's clockwise or counterclockwise. 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 Aha. Counterclockwise now. All right, cool. All right. So let's see. Our tool, we are going to pick our 1/4 inch chamfer tool. We can go fast. Okay. And then I will tell it chamfer C-bore holes. Cut parameters. All right, we're going to do a 2D chamfer. Our chamfer width is going to be set to 0. We're going to go right since the chamfer is modeled in. And we're going to offset by 0.05. It needs to be larger than the chamfer itself. That's our big thing. Lead in, lead out. We know I like the 30% because it seems to work pretty good. Linking parameters. Let's see. I like the 0.2, 0.1, top of stock. Top of stock at negative 0.25 is fine. That is right where this edge is. And remember, if you look at our cut parameters here, we hang down an extra 50 thousandths, so it'll be perfect. Okay, there we go. Okay, so we've chamfered those guys. We also want to chamfer this guy right up here. And that's an easy one. It's not a 3D chamfer, so we're going to do that guy next. Contour. Okay. I'm going to pick the top of the chamfer. Make sure you pick the top. We don't want going that way. We want it going counterclockwise. Okay. Everything's going to be the same as the last one. Okay. Chamfer, large hole, I guess. That sounds good. Hole. There's only one of them. Cut parameters, let's see, we have a 2D chamfer, hang out by 50 thousandths, set to where, lead in, lead out should be at 30%, good. Linking parameters, we're going to go 0.2, top of stock is 0 because this is our top surface. And we're going to go depth of 0, but remember, we hang down by 50 thousandths. Planes are G54, coolant should be flood on. Let's double check here, yep. All right, there we go. So now we've chamfered the stuff that you guys are used to, that you've seen a lot. And we're going to save again just because. So now we're looking at doing our last of the chamfers. These are 3D chamfers. I'm going to show you how it should work. Okay? keep in mind, it might not work right. I've been having problems with my model. We'll see if you have problems with your model. Okay, so we did a 2D chamfer around there, and then I think I accidentally deleted the 2D chamfer that was in the center. I'll come back and do that later. So we're going to do the 3D chamfers around here. We're going to do a contour. We're going to pick edges. Doesn't matter where you start. You pick here. I mean, it matters where you start because that's where the tools start, but we're just going to move along the edge here. You could have hit shift and select the whole thing. All right. For our tool, we're going to pick our 1/4 inch chamfer mill. We can go pretty fast along there. We won't quite do 60. Let's cut it down to 40. Okay. 3D chamfer outside top edge. Cut parameters. We want to do a 3D chamfer. We'll hang out the bottom by 50 thousandths. We don't need to add width, and we're set to where. Cool. Lead in, lead out. We're going to leave it our 30%. And linking parameters, 0.1, 0.20, and then this handles it because it started at -0.25, but then it takes care of the rest of it because of it being a 3D. Planes, coolant should be on. Okay, and you got a 3D chamfer. Holy smokes, hold on. That sucker's hanging down a lot. Let me see what's going on here. I'm going to guess it's... No, it's not there. I thought it was going to be that. Oh, it's incremental. 0. Okay. There we go. That's what we want. Okay. Now, this looks great. Let's go do the 2 others, and then I'll tell you about the problem. All right, we're going to do another contour. We can go ahead and hit shift and pick this whole loop right here. Okay. That is the direction we want to go. Inside of things, we go in a counterclockwise direction. I'm going to end that chain, and then I'll do it again here. Let me get it to fit. I'll zoom in there. Okay, cool. Okay, let's go in counterclockwise again. So we're looking good. Our tool, we can go pretty fast on this one also, but we'll say 3D chamfer pockets. Sounds good. Cut parameters, 3D chamfer, hang out by 50 thousandths. Lead in, lead out, set to 30%. We're not entering and exiting a midpoint or linking parameters. So incremental 0, cool, top of stock is 0. All right, incremental means you're going to touch the line. The selection we chose, you're going to touch that. Coolant should still be on. All right. Again, looks relatively good. Now, let me fix that one that I accidentally deleted right here. So in case you've never really edited, I'm going to move that guy before my 3D chamfers right there. I'm going to do a quick one. You don't have to do this. I deleted mine on accident. There we go. I'm going to revert. Wait, that is the right direction because we are inside of a circle. Sure. Chamfer, big hole. 2D. Oh, I got to be a 2D chamfer. Hang out by 50. Cool. Lead in the outs at 30. Good, good. And then I'm going to move my red arrow down below that. Okay, so in theory, you're done. Okay, if you were to hold down shift and go up to the top, apparently nothing happens. Try that one more time. Shift, and we'll go down to the bottom here. All right, there's all our toolpaths. Okay, if we run this thing, it will all machine, everything's cool. There's one problem. If you look very carefully, there's a squiggle. And I gotta be honest with you, I racked my brain trying to figure out why it's doing that. And I honestly don't know why. I'm gonna keep doing some more research. And if you notice, when you flip it around, Same squiggles on the opposite side, okay, or across it. So if yours does not do that, you're done. Yay, save, turn it in, congratulations. But if you're going to make this sucker, we got to figure out why. So I figured out a trick. Okay, we're going to go into our parameters, and we're going to go back to our toolpath type, and we're going to pick no geometry, and then we're going to select chains. Now, check this out. This is where it appeared, and it appears on the opposite side, kind of kitty corner across it. I'm going to start it right here. I'm going to go, oops, I'm going the right direction. I'm going to go all the way around until right there. End chain. Then I'm going to start again. Okay. And I'm going to go all the way around. And I hit end. And I hit OK. And it's weird. So I start and stop it in two places. But there's not the squiggle. And I can't tell you why. Same thing happens here. You're looking at this like, oh, it looks cool. And then you see that sucker. And trust me, see that drop? You will notice that when you machine it. You might say, Parks, how do you know you'll notice it? Because I made it like that. And it's a big oops. It's cruising along, just chamfering me. All of a sudden you hear this, and it didn't break the bit or anything, but it would have scrapped the part. And it does it at the very end after a very long toolpath. So you got to do the same thing here. It starts on that. The problem is there. And then the problem is there. So that's where we're going to start and stop. Seems really lame. It's the only thing I could figure out that works right. All right. So we're going to start right here. And then, wait, we like to go counterclockwise, inside holes. So we're going to start here. We're going to work our way around it. End chain. Happens at the same spot on the other side. Like directly across, not directly across, diagonally across. And we want to go counterclockwise, so we're going to start here. Okay? I'm going to work my way, oops. I'm going to work my way around it. Hit OK. Hit OK again. And you will notice there is no weird little jagged thing that shows up. If I can't figure it out, I'm actually just going to make a little video of this and email Mastercam. I have a feeling it's my model, but I'm not 100% certain, to be honest with you. So when you're all done, hit Shift and pick all of them like that. Maybe zoom out some. And that would be a great screenshot to show me. You could, well, let's hit Save. You could backplot this thing. You could also do a full verify. You just got to remember to make your stock. Okay. But yeah, that's what she'll look like. It is a very long cycle time, I will warn you. We're going to play with some things. We're going to see if we can save us some time. But this is how Titans of CNC Academy recommends you do it. And this would result in a very high quality part. We may make some alterations, mostly in how far our step overs are. That'll make a big difference on how fast this thing goes. So there she is, everyone. Save that guy. Save your screenshot of this. Turn in the screenshot and the Mastercam file for me. And good job.